Sources of methane emissions due to human activity. Year 2020 estimates increasing methane emissions are a major contributor to the rising concentration of greenhouse gases in Earth's atmosphere, and are responsible for up to one-third of near-term climate warming. During year 2019, about 360 million tons of methane were released globally through human activities, while natural sources contributed about 230 million tons. Reducing methane emissions by capturing and utilizing the gas can produce simultaneous environmental and economic benefits. About one-third, plant agriculture, including both food and biomass production, constitutes a fourth group, with rice production being the largest single contributor. The world's wetlands contribute about three-quarters of the enduring natural sources of methane. Seepages from near-surface fossil fuel and clathrate hydrate deposits, volcanic releases, wildfires, and termite emissions account for much of the remainder. Contributions from the surviving wild populations of ruminant mammals are vastly overwhelmed by those of cattle, humans, and other livestock animals. The atmospheric methane concentration is increasing and has exceeded 1860 parts per billion as of year 2019, equal to 2.5 times the pre-industrial level. The methane itself enables a direct radiative forcing that is second only to that of carbon dioxide. Due to interactions with oxygen compounds stimulated by sunlight, CH4 can also increase the atmospheric presence of shorter-lived ozone and water vapor, which are also potent warming gases that amplify methane's near-term warming influence in a mechanism that atmospheric researchers distinguish as indirect radiative forcing. When such interactions occur, longer-lived and less potent CO2 is also produced, including both the direct and indirect forcings. The increase in atmospheric methane is responsible for about one-third of near-term climate warming. To compare the warming to that from carbon dioxide over a given time period, methane in the atmospheric has an estimated 20-year global warming potential of 85, meaning that a ton of CH4 emitted into the atmosphere creates approximately 85 times the atmospheric warming as a ton of CO2 over a period of 20 years. On a 100-year timescale, the GWP is in the range of 28 to 34. Though methane causes far more heat to be trapped than the same mass of carbon dioxide, less than half of the emitted CH4 remains in the atmosphere after a decade. On average, carbon dioxide warms for a much longer time period assuming no change in rates of carbon sequestration. Abiogenic methane is stored in rocks and soil stems from the geologic processes that convert ancient biomass into fossil fuels. Biogenic methane is actively produced by microorganisms in a process called methanogenesis. Under certain conditions, the process mix responsible for a sample of methane may be deduced from the ratio of the isotopes of carbon, and through analysis methods similar to carbon dating, a comprehensive systems method from describing the sources of methane due to human society is known as Anthropogenic Metabolism. As of year 2020, the emission volumes from some sources remain more uncertain than others, due in part to localized emission spikes not captured by the limited global measurement capability. The time required for a methane emission to become well mixed throughout Earth's troposphere is about 1 to 2 years. Natural sources have always been a part of the methane cycle. Wetland emissions have been declining due to draining for agricultural and building areas. Unlike most other natural and human-caused emissions, fossil fuel extraction and burning yields a net transfer of carbon between major storage pools in Earth's biosphere that will persist for millennia. In total, humans extracted about 400 billion tons of geologic carbon through year 2015, including half in just the last one-third century and at an increasing rate of about 10 billion tons per year. The magnitude of this transfer exceeds that from any other known geologic event throughout all of human history. About 50% of the transferred carbon presently resides in the atmosphere in the form of elevated CO2 and CH4 concentrations, while most of the remainder has been taken up by the oceans as an increase in dissolved CO2 and carbonic acid, especially near the water surface. By contrast, the magnitude of the terrestrial sink has remained relatively constant. This carbon redistribution is the root cause of recent rapid global warming, ocean acidification, and their resulting impacts to life. Some of the largest effects, like sea level rise and desertification, occur over time due to the vast inertia of the Earth system. Assessing these and other environmental threats to the sustainability of human civilization are topics within Earth systems science, including the recently proposed comprehensive framework of planetary boundaries. Despite the probable crossing of multiple bound